Okay, this is going to be chapter chapter 2.x sub 1b, which is going to be limits part 2, limit laws. Okay, so these are the limit laws. I'm not going to write it out. The important part is you convince yourself these are true. Okay, so all this means is that you can add them and subtract them, and you can apply the limit on them, and everything's fine. This is constant multiple, which means if you have, for example, the limit as x approaches 7 of 2x, that's the same as saying 2 limit x approaches 7 of x, right? I want you, yes, you, to derive this, derived from law 1, which says the limit as x approaches a of f of x plus g of x is equal to the limit as x approaches a of f of x plus the limit x approaches a of g of x. Okay, so take a quick pause and I'll run it back. I'm gonna run it back. Okay, so the way you do it is you kind of rationalize to yourself that, oh, if the limit as x approaches a of f of x plus g of x is the same as the limit as x approaches a of f, I'm gonna stop writing of x, okay? Plus the limit as x approaches a of g, then if let's say 2f of x is what you're looking at, then you're really looking at f of x plus f of x, right? And because this is in the same form as this, you can just apply it here and here. Sorry, wait, here and here. So your g of x is actually your second f of x. Okay. Similarly, for the product, right? You know that you can take the first one, multiply the second one, and take the limit. Or you can take the limit of the first factor, multiply by the limit of the second factor. Okay. So for example, the limit as x approaches 1 of x times x plus 2 is the same as the limit as x approaches 1 of x plus the limit as x approaches 1 of x plus 2. Ooh, not plus, I'm so sorry. Times, which is going to equal 1 times 1 plus 2 is 3, which is 3. It's reasonable, I think. Positive integer power. So for example, let's start with what it means. What it means is you can take some function, raise it to the n, and then take the limit, or you can take the limit of the function and then take that limit and raise it to the n. Okay? And so for example, the limit as x approaches 2 of x cubed, right? Is going to actually let's do something different. X approaches 3 of x squared, right? Is going to equal the limit as x approaches 3 of x times the limit as x approaches 3 of x, which is going to equal 3 times 3, which is 9. Okay, so all cool with this? Cool. Note, n is an integer greater than or equal to 0. Okay. The last thing we'll cover is the quotient. That's pretty straightforward. Limit top divided by limit bottom. Same thing. All right. Okay. The important part is what I'm about to show you, which is the flowchart. Okay. So let's say you have a limit and you don't really know what to do with it. This is the most reasonable course of action. Ready? One. And so let's say you have like limit as x approaches a of f of x. Right? So one. And you find f of a. Like, is it reasonable to plug in? Yes, do it. No. Can you simplify? So by that, I mean, can you factor and cancel out? Can you multiply by the conjugate? And these are all things you guys should know how to do, so I'm not going to go over it. Can you rationalize, especially denominators? This mostly deals with fractions, okay? If yes, do it. And then you're going to loop back up here. If you cannot simplify anymore, and you L'Hopital it, um, this you're not allowed to do yet. So for now, the answer is going to be no. Okay. If you can L'Hopital it, do it. If you cannot L'Hopital it and you cannot simplify anymore, give up. No, I'm just kidding. Does not exist. Explain why. Like, do the ends go up funny? Do they both go up to positive infinity or negative infinity? Stuff like that. Okay, that's it. That's the flowchart.